Welcome back, friends. I know it's been a while since we've done one of these videos. Hurricane season out in the Atlantic, at least, has been rather quiet. Now that we're in August, we're getting towards that point where we're going to start to see the season ramp up in activity, at least climatologically speaking. Looking back here over the past, several decades, you see the big uptick in that hurricane activity, of course, when conditions get a little bit more conducive for the tropical storms to develop and become hurricanes, warm waters, low wind shear, overall favorable conditions in the tropical Atlantic. That seems to peak around September 10th. Ocean waters at that point in time are usually the warmest, and they lag a little bit as we get towards the later part of the season. But again, this goes for about another 4 months. We're only a third of the way through, ends on November 30th in the Atlantic basin. We'll start there today to talk about how quiet it has been. Really, since we had Beryl and Chris, both hurricanes, back in the early part of July, things have been rather quiet. Now, you look at it here and you notice, well, look at that, coming off the coast of Africa. Pretty robust tropical African wave. Not so much. It looks good coming off the continent, but once it hits these somewhat cooler ocean temperatures, as well as very dry air, a lot of sinking motion out in the middle of the tropical Atlantic here, the main development region, as we call it, and this is going to quickly put the kibosh on this developing any further. And there's also several more aspects of why things have been quiet there, and we're going to go through them a little bit one by one. First, what you're looking at here is another satellite imagery, but a different filter on it. This is the water vapor imagery, and this depicts moist air and very dry air. A lot of dry air out there. The only moisture associated with that African easterly wave that's emerging over the very far eastern parts of the Atlantic, and it's kind of getting absorbed by all the dry air. It's going to take a lot to kind of saturate the atmosphere out there, and that's not happening anytime soon. So the main development region here is what we're talking about. Cape Verde storms usually come off the coast there and develop in this region. And over 50% of all major hurricanes, Category 3 storms or greater, develop within this region. We expand that through the Leeward Islands and into the Caribbean, and then you get 75% of all the storms that develop there. So it's a large percentage, but it's not the only place that tropical systems can develop, and we're going to get to that in a second. So out there in the main development region, you've probably heard a lot of talk about their sea surface temperatures. Oh, it's so cold out there, we're not going to have any Atlantic hurricanes. Okay, it's cooler than average, but it's certainly not cold. You need 80-degree temperatures or greater, and this has to do with the physics, evaporation, eventually the release of latent heat, which is fuel for these storms to develop, of 80 degrees or warmer, and that's typically when you get to ideal conditions. Beryl, on the other hand, when that formed into a hurricane in the far southern end of the MDR, the main development region, back in, I think it was early July that developed in water temperatures that were 78 to 79. So it's not always it needs 80-degree waters or warmer, but most of the time. And you see some of these temperatures here, certainly a few degrees below that 80 degrees that we would need. But the farther south you get, obviously, it is a little bit warmer. So we'll wait for this to warm, which it will do through the rest of the month of August. And we'll see what happens there. So sea surface temperature anomalies, this big blue region here, indicates water temperatures that are cooler than the long-term average. You go to the south here in the yellow, and that's what we're looking at, temperatures a little bit above the long-term average there. So kind of split in half. Not all of the main development region cooler than normal, but certainly a large chunk of it. On the other hand, look at what's happening here as you cross the Leeward Islands, head into the Caribbean, the southwestern parts of the Atlantic Ocean, and then the Gulf of Mexico. We are cooking out here. Some of these sea surface temperatures are in the upper 80s, and nearly 90-degree water temperatures in the central Gulf of Mexico. So this area is primed for tropical development. We just need some spin, a remnant low to develop out in the Atlantic and head into this area, and things can get rather interesting. You look at the anomalies here, a lot more yellow shading than what we saw in the tropical Atlantic, so these waters are running above the long-term average. Also, something that's putting a cap on the development in the tropical Atlantic, the main development region, is the Saharan dust. You may have heard a lot about this, too, because a lot of these plumes have survived long enough to make it all the way into Mexico and parts of Texas, as well as Hispaniola and the Caribbean. That made for those red sunsets out there. If you are joining us from those areas and you saw that, that's the Saharan dust. Very strong winds coming off the continent of Africa, picking up the Saharan dust in the desert and bringing it to high levels of the atmosphere. And that's essentially bringing a lot of dry air out here, like we saw in the water vapor imagery. So tropical systems just can't really develop. Now, since it's quiet in the Atlantic, It's the complete opposite, pretty much, in the Pacific. We are already on our 8th named system of the year, and that is HECTOR. You can see it here out in the front of a line of tropical waves that are beginning to develop. In fact, these two behind, we're going to talk about something very interesting that the models are depicting with that. But first, let's talk about HECTOR. This developed yesterday as a tropical storm, quickly strengthened overnight to a Category 2 hurricane. Within the last update from the Hurricane Center, it has been downgraded to a Category 1. But also look at how close it is, close, in the big perspective, really, to Hawaii. It's about 1,700 miles away from it now. But with the steering mechanisms that are in place, a big subtropical high here, it is going to be steering HECTOR awfully close to the big island of Hawaii by the time we get to Tuesday and Wednesday of next week, and pull it a little bit to the north, closer to the island. You could see that depicted here on the Hurricane Center forecast track. Of course, the farther out in time you get, that cone of uncertainty gets much, much larger. Here we are at the end of that, the outermost fringe of that, the westernmost flank of the cone of uncertainty, almost near the big island of Hawaii. And here we are very early in the morning on Wednesday. At that point, still a Category 2 hurricane. So let's talk about the models, how it sees it. Each line you're seeing here is a different computer model and its forecast track out into the future. Again, some take it right over the big island of Hawaii, some a little bit to the south. All pretty much would bring some sort of impact to the state of Hawaii. Now, that brings to light, when was the last time that happened? Not too often. It's actually quite rare there, but in the last 10 years, not so rare as what it's been for like the last 50 years. We've had 2 tropical storms impact the islands there, and that was in 2016, Darby, Iselle in 2014, and then Iniki was the last major hurricane to hit that area back in 1992. So look at the span of time from 1992 to 2014, over 20 years there. So been quite a while there, just rather active in the last 5 or 6. Now, out behind HECTOR, 2 other systems. No name yet, just invests out there in the tropical Pacific. But I'm going to show you something here. This is the GFS model, one of the global forecast models that we use here. And watch as we go out in time. We're going to see the 2 storms get picked up by the models here as we go out through the weekend. There they are, very minimal grade systems. But as we go farther out in the future, notice what happens here. They get stronger, they get closer together, and then eventually they get close enough to impact each other's track. They orbit around each other and then merge into one. This is something that's extremely rare. It's called the Fujiwhara effect, and in essence, it's 2 storms colliding and becoming one. So it usually happens when we have 2 storm systems that are similar in strength. There's always one that's got to be a little bit stronger than the other. They get very close. They start to influence each other's track. They orbit around a central point, and eventually the stronger of the 2 storms will kind of engulf the other and become one somewhat stronger storm at that point. So very cool there to see if the model's depicting that and it actually comes to fruition here in the next week, week and a half or so. So very interesting out in the Pacific. We'll continue to watch the tropical Atlantic for you. Until then, if you're joining us on YouTube or Facebook, you have any questions, feel free to reach out. I'm on social media, Facebook meteorologist Tim Pandajis, and also on Twitter, 13 Tim Pandajis. I hope you have a great weekend.